Good morning, dear students. My name is Ferhan Mazher, and today is 5th of October 2021. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper, and the paper which we have selected is May-June 2021 2-2 paper. This is a theory paper from the Zone 2 or Variant 2. And in my previous, in another session, we have already solved its section A. Today, we are going to solve the section B of this paper. The section B of this paper has three questions. Question number 9, question number 10, and question number 11. So we will solve section B of this paper in this video. So let's start. This is May, June 2021, Physics 5054, 2-2 paper. So let's start. So So the first question which is coming up on your screen is question number 9, and you can see this. So question number 9, A part is, he says figure 9.1 represents the conversion of the energy in a mobile phone. So here we have a battery, and this battery, we put this in the mobile phone. So the battery is providing energy to the mobile phone, and mobile phone is providing some energy output are given by the cell phone. So the first question is, state the form of energy stored in the battery. The batteries always have chemical potential energy in them. The next part is, state the useful form of the output energy from the battery. The useful output form of the battery is electric energy. Battery provides you with the electric energy. The next question coming up on your screen is of 2 marks. It says, state 2 useful forms of the output energy from the mobile phone. From the mobile phone, the useful output energies are light energy, sound energy, electromagnetic energy. The B part is, when the battery is in use, the average current is 1.3 milliampere. Determine the charge that passes through the battery in a time of 2 minutes. You see, here the amount of current is given, and that is 1.3 milliampere. Here the time is given, which is 2 minutes. They want you to find out the amount of charge. You know, the I is equals to Q divided by T, where Q is the charge, I is the current, T is the time. So if you want to find out the charge Q, that's Q. So make the Q alone, and it will be equals to I multiply T. Very simple. So let me show you my work. I've done this on a paper. So this is question number 9. Okay, so from here. Okay. So on your screen, question number 9, my solutions, they are showing up. Here we go. So chemical potential energy, electric energy, light, sound, and you can also say electromagnetic. Now here, the current is given, that's 1.3 milliampere. Milli means, if you convert this into amperes, that will be 1.3 x to minus 3 ampere. The time is given in 2 minutes, but in this formula, the time must be always taken in seconds. So I convert the 2 minutes into seconds. How you multiply? In 1 minute, you have 60 seconds. So 2 minutes will have 2 multiply 60, and that will be 120 seconds. So I is equals to Q divided by T. That's the formula, famous formula. If you want to find out the Q, that will be equals to I multiply T. So I value is 1.3 x to minus 3 multiply 120, and you will get 0.156 coulomb. So if you round it off, it will be 0.16 coulomb. 0.16 coulomb. So that will be the charge on the charge which will pass. Okay. Then we have, let me show you the question from the question paper, and then we come here. Okay, so we are done with this part. Okay, so the next question coming up on your screen is a 3-mark question. Let me increase the size so you can see the whole thing. Okay, he says that a student estimates the thermal energy produced in the battery when the mobile phone is used, and uses this value to estimate the efficiency of the battery. He measures a temperature rise of 5 degrees centigrade within the battery in a period of time when the useful energy output from the battery is 5200 joules. The mass of the battery is 110 gram, and its specific heat capacity is 830 joules per kg per degree centigrade. Calculate the thermal energy heat needed to raise the temperature of the battery by 5 degrees centigrade. If you want to know the amount of heat required to raise the temperature, the process is very simple. You see, heat is equals to mc delta theta. Heat is equals to mc delta theta. M is the mass, c is the specific heat capacity, and delta theta is the change in the temperature. Delta theta here is 5 degrees centigrade. C, specific heat capacity is 830 joules per kg per degree centigrade. M is 110 gram, but there's a problem. You see, if you look at carefully, the mass is 110 gram, its unit is gram, but the unit of the mass used in the specific heat capacity is kg. So what I need to do is I need to convert this grams into kg. So this is a 3 marks numerical. So let's see, let's go to my solution and we will see what we have done there. So here we go. So on your screen, the solution is coming up. Heat is equals to mc, heat is equals to mc delta theta. The mass is 110 gram. To convert it into kg, I will divide it with 1000 because in 1 kg there are 1000 grams. The C value is 830 joule per kg per degree centigrade, and the delta theta change in the temperature is 5. Just do enter them in the calculator. The final answer will be 456.5 joules, which you round it off to two significant figures, and that will be 460 joules. So this is a 3 mark numerical. I hope you have understood. The next question is state what is meant by efficiency. Let me show you first this question from the paper so that, okay. Now, the question coming up on your screen is this. He says, state what is meant by efficiency. You know, the efficiency means useful output energy divided by total input energy. So you can say that efficiency is the ratio of the useful output energy to the total input energy. And then the next question is calculate the efficiency of the battery. You see the efficiency of the battery. The battery has provided two things. The battery is providing you, means the energy which the battery provided, that will be the input, and that is equals to the this useful output plus the heat which the battery provided. Okay, so we will add them up and then we can find the efficiency. So let me tell you, very simple. You see, the efficiency of this battery is equals to, you know, the useful output energy that is given. It is 5200 joules, and the total input energy is the battery provided this useful plus the battery provided the heat. So add them up. That will be the total input energy provided by the battery to the mobile. So that total energy provided by the mobile battery. Sorry. So it will be 5200 divided by 5660 multiply 100. So that will be something like 91.8%. So when you round it off, it will be 92%. So the efficiency of this battery is 92%. Hopefully you have understood this question. The next question coming up is, let me show you the question. That was the question. And then he says, suggest and explain one reason why the value for the efficiency calculated in the third part is larger than the actual efficiency of the battery. You see here, we thought that the battery is providing the useful output energy plus it is providing the heat energy to heat up the cell phone. So, or heat up the, you know, but you know, when the battery have provided the input energy by the battery will be more than which we just used, because the heat which you are providing is not only used to heat up the cell phone, it is also lost to the surrounding. So lot of heat is also lost to the surrounding, which we have not included in the input energy given by the battery. You see, we have not included the heat which has been gone to the atmosphere. So that must have been included in the input energy. So if you put the heat which gone into the atmosphere into the input energy, then the efficiency will go down. So that's why the efficiency which we calculated is larger. The actual efficiency will be smaller. I hope you have understood this idea. Let me show you my answer. And this says that some heat will be lost to the environment. So heat required to raise the temperature by 5 degrees centigrade should be larger, because the heat used to raise that the temperature of the cell phone by 5 degrees centigrade. But with this, you need heat which will be lost to the surrounding also, because this is not possible that some of the heat has not lost to the surrounding. That is not possible. Some of the heat will be lost. So that should also be included in the input energy. Then the efficiency will go down, obviously. So the efficiency will be smaller. The actual efficiency will be smaller than the efficiency which we calculated, because we have not included that heat which was lost to the surrounding. And that heat was provided by the battery. So that was the the waste energy will become larger. So the efficiency will go down. Okay, so hopefully you have understood. So that was question number 9. I can reduce the size of this question. So it's a 15-mark question. Only the last part was little difficult. Rest of the question was very simple and straightforward question. 15 marks question, very easy question. So now let me show you the marking scheme of the chapter question number, okay, so here we go. So we have to reduce it a bit. Okay, so this is the question number 9, not the whole question. Okay, so this is the question number 9, and you can have a good look at this marking scheme. It is very, very, very important to look at the marking scheme. Okay, so this is question number 9, A part and B part, and you can pause the video, you can see them. And here we have the question number 9, and it's C part, and so you can pause the video and you can have a good look at this marking scheme. So this is question number 9. Okay, so we are moving to the next question. That's question number 10 coming up on your screen. Okay, so here we go. Figure 10.1 shows a water wave moving from shallow into deep water. The wavefront shown represents the crust of the wave. So these are basically wavefronts, okay, and they are basically the crusts. So these are wavefronts. Here the water is shallow, here the water is deep. The water wave is made by dipping a wooden bar up and down in the water. The bar makes 10 complete up and down movements in 5 seconds. Determine the wavelength of the wave in the shallow water. So here you can see, here they have shown that this is 12 centimeter, and you just need to count how many waves are there in these 12 centimeters. So here we have 1, 2, 3, 4. So there are 4 gaps. So that means there are 4 waves. Okay, so there are 4 gaps of 4 waves, and so the total distance is 12 centimeter. In 12 centimeter, we have 4 waves. So the wavelength, which means the length of one wave, and that will be 12 divided by 4. So if you do 12 divided by 4, you will be able to find out the wavelength. So let me show you. So here we go, and he says, what is the wavelength? And we measured, that was given in that diagram. There were 4 waves, and the total distance between them was 12 centimeters. So divide the 12 centimeter with the 4. So the one wavelength will be 3 centimeters. So the lambda is 3 centimeters. Then he says, calculate the frequency of the waves produced. So they are producing 10 waves in 5 seconds. So if you want to know the frequency, the number of waves divided by time. Very simple formula. Frequency will be equal to the number of waves produced and divided by the time taken to produce those waves. They produce 10 waves in 5 seconds. So 10 divided by 5, that will be 2 hertz. So the frequency is 2 hertz. The frequency is 2 hertz. The next question is, determine the speed of the water wave in the shallow water. In the shallow water, I know the wavelength, that is I know the wavelength, that is 3 centimeter. I know the frequency, that is 2 hertz. So simply, you know the famous wave equation, V is equals to F lambda. V equals to F lambda, where V is the wave velocity or speed, F is the frequency, lambda is the wavelength of the wave. So V will be equals to 2 multiplied 3, that will give you 6, because the lambda was measured in centimeters, so the speed will be centimeter per second. Remember one thing, if the lambda is measured in meters, then by using this formula, the speed will be meter per second, because we have measured the lambda, we have used the lambda in centimeter. That's why the speed, the unit of the speed will be centimeter per second. So 6 centimeter per second. So 2 marks numerical. Hopefully you have understood. Okay. So the next question coming up on your screen, let me show you from the paper first of all. Okay, so we are done with this. So the next question coming up on your screen is, he says that on the figure 10.2, draw lines to show what happens to the wavelength, the frequency, and the speed of the water wave is enters the deep water. You know, when the water wave, he's talking about this diagram, when the water waves will enter into the deep water, you can see, you should know one thing, that there will be no change in the frequency. When the water waves enter from the shallow water into the deep water, or they enter from a deep water into shallow water, there will be no change in the frequency. So the frequency will remain same. Now, as you can see here, the wavelength is smaller, here the wavelength is larger. So it means that the wavelength will increase. The frequency will not change, but the wavelength, you can see here in the deep water, the wavelength has increased. And remember my words, that when the water waves enter from the shallow water into deep water, their wavelength increases, so their speed also increases. In the deep water, the speed is larger, the speed is higher. So what will happen? The frequency will remain unchanged, it will stay constant, it will remain constant, and the wavelength will increase, as you can see from the diagram, and the velocity will, or the speed will also increase. So if you look at this diagram, he said on the figure 10 point, draw the lines to show that what happens to the wavelength, the frequency, and the speed of the wave. The wavelength will increase, that is given. Frequency stays the same, and the speed also increases. Don't confuse and join the speed with the speed with this decrease thing. Speed will also increase. If the wavelength will increase, speed will increase. If the wavelength will decrease, the speed will decrease. Remember this. Frequency do not change. So the next question coming up on your screen, he says, the direction of the boundary is not altered. The water wave now enters the deep water from the shallow. So this is shallow water, this is deep water. Shallow water at an angle as shown in the figure 10.3. On the figure 10.3, draw the wavefronts in the deep water. It's a 3-mark question, very important question, and it requires a lot of attention also. So let me go back and, okay. So pay attention, it's a very important question. So when the water wave will enter from the deep, shallow water into the deep water, the wavelength will increase, the frequency will stay the same, the speed will also increase. Okay, so here we have question number 10, a fifth part. So first of all, I will draw the line of direction, the direction of the wave. How does the direction, what is the direction of the wave in the shallow water? So for that purpose, you see what I have done. I have taken a protector and I have aligned it with this direction line, the given direction line. So I will draw a line here. So that line will show the direction of the wavefront. So in which direction the wave is going, in which direction the wavefronts are going. Okay, so here in the second step, you can see that I have drawn that line. This red line is showing that line. So this is basically showing you the direction of the wave. So the waves are going in this direction. So I prolonged it until it touched the boundary of the shallow and the deep water. So that was step number two. Then in the third step, what I will do, where the direction line has touched the boundary between the deep water and the shallow water, I will take a protector and I will place that protector. You see what I will do? I will place that protector on the boundary. You can see this zero and this zero is on the boundaries. And the crosshair of that protector is on the point where the direction line touches the boundary. So I will put a dot here at the 90-degree mark because I want to draw a normal. So I will put a dot here on the paper. So I hope you understand what I'm doing. Then I will join that point with this point and I will prolong this. So this blue line is basically representing the normal. So you see how I have drawn this normal. So there is no calculation involved. There is only one concept, that when the water waves, they enter from the shallow water into the deep water, their speed increases. So when their speed increases, they bend away from the normal. So because the speed of the water waves will increase when they will enter from the shallow water into the deep water, so what will happen? They will bend away from the normal. That is the rule of the waves, whether they are light waves, whether they are sound waves, whether they are water waves. If their speed will increase, if they move from the one medium into another medium, and their speed will increase, they will bend away from the normal. And if their speed will decrease, they will bend towards normal. But here, the water waves, their speed will increase, so they will bend away from the normal. So here, there's no calculation involved. Simply, this was the direction line, and original path is this, but I will bend it away from the normal. So you can see this red line. This is showing that the water waves will bend away from the normal. So no calculation involved, only this concept. Okay. Now it's very tricky. Now I will use that protector, and you see this 90-degree mark in the protector. I will put that on that refracted direction. This red line, which is showing the direction of the wavefronts in the deep water, I will put that protector on that line in such a way that this is exactly coinciding with the 90-degree. This line of the 90-degree, I have put it on that. Now I will move this protector little towards this side. So when it coincides here, when this edge of the protector coincides with this wavefront, when it touches the boundary, here with the pencil, I will draw a line. So you can see here, you can see that I have drawn this line. I will again put the protector on this red line, which shows the direction of the wave. And it's the 90 of that protector should be on this, and the crosshair should also be on this. And I will move little towards this side, to the left side. When this straight edge will coincide with this point, I will draw a line there. So let me show you. Okay, so you can see I put the protector on that red line, which shows the direction of the waves. And you can see the crosshair and the 90 both are on this red line. So I moved it towards the left. So when this straight edge of the protector coincides with this point, where the wavefront in the shallow water touching the boundary, so there I will with the pencil draw a line here. That will show the wavefront in that deep water. So I will draw a line here. So here you can see that second wavefront I have drawn. So then I will again put my protector in such a way that the crosshair and the 90 both are on this red line, which is in the deep water, showing the direction of the waves. And I will move it further to this way. So whenever it coincides with the wavefront, which touches the boundary here, a wavefront in the shallow water, visiting the boundary. I will find here. So here see that I have drawn. So my dear students, I hope that you can see that I have how we have drawn those wavefronts. So okay, so let's move. This is how you draw those wavefronts, and I hope that this is you have understood. Okay, so let's move to the next question. And so here we go. We are done with this. That's question number 10, and now we are question number B part. He says white light is made up of different colors. State the name of 4 of the colors in the spectrum and place them in order from the smallest wavelength to the largest wavelength. Okay. So for example, the first 4 colors are red, orange, red, orange, yellow, green. But here the order, first of all, you have to write that one which will have the smallest wavelength in those 4. So let me show you. It can confuse you. Okay. So because because he said I have taken the first 4 colors. The actual order is red, orange, yellow, green. But he said write first that one which will have the smallest wavelength in those 4. So that's why green. And at the bottom, I've written the largest wavelength, that has red. Red has the largest wavelength. So green, yellow, orange, red. So you see, this is a very tricky question. Just he's checking your common sense. Okay. Now, the next question is coming up on your screen. He says, okay, so here we go. He says figure 4 point, let me reduce the size so you can understand the whole thing. Okay. A narrow beam of white light can be split into different colors. Figure 10.4 shows rays of white light emitted from a lamp. Complete the figure 10.4 to show how a narrow beam is produced from these rays and how a spectrum is shown on the screen. Label your diagram. So here you know this figure 10. So here I have to use a card, and that card will have a small slit here. So a narrow beam of light is produced. Then I will put a prism here, and due to when the light will pass through the prism, the spectrum will take place and dispersion of the light will take place, and a spectrum of will produced here on the screen. So let me show you here. So here we have the question number 10B, second part. You can see here we have put a cardboard, and that cardboard has a small slit in it. So this will make a beam of light to come out. And then we have put a prism here, a glass prism. And you can see that when the light entered into the first phase of the prism, the refraction of the light will take place, and the light will convert it into its 4 colors. And when those colors will come out from this, they will emerge from this phase of the prism. They will come on the screen, and there will be a band of colors. And the order of the colors will be Roy G. Biv. Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. And red, orange, yellow, green, blue, indigo, violet. So hopefully you understand. So that was the question number 10B, second part. Okay, so let's check the question number 10. So we are done with the question number 10. So my dear student, that this was the question number 10. So this was on 3 pages. question number 10, A part, and B. Then we have A part have so many parts, and then B. So we are done with the question number 10. So let me show you the marking scheme, and so that you can understand, you can check your answers yourself. Okay. So on your screen, my dear students, the marking scheme of the question number 10 is showing up, and you can have a good look on this. So you can pause the video and you can look at the marking scheme, because this marking is showing up. It's very important that when you ever have solved a question, after solving the question, you check your answers and you match them with the marking scheme. So this was the question number 10A part, and now you can see these are the parts. You can pause the video and you can have a good look at this marking scheme. Okay. Okay, so let's go to the next question. The next question coming up on your screen is question number 11. Here we go. A highly radioactive source that emits beta particles is placed a few centimeters away from a detector, as shown in the figure 11.1. So here we have a source which is giving out radiation, and it's giving out beta particles. And you can see here we have put a metal casing around it. And here we have a detector GM tube, and it's telling you how much is the count rate. State the name of the particle which has the same mass and charge as the beta particles. The beta particles have a negative charge, and they are like electrons. So the other particle which has the same mass and charge, that is electron. So here you will have to write the electron. Then his question is state and explain why the metal casing in the figure 11.1 is used. You see the beta particles. They cannot penetrate through the thick metal casing. So we have put a thick metal casing around it, so the radiation do not. For example, if the students who are performing that experiment, they are standing here, so that radiation is not directed towards them. They are not exposed to that radiation. The radiation will be only directed out through this slit, and it will be towards the detector. So only the radiation is going towards the detector. So that's a kind of safety precaution. Because the beta particles, they cannot penetrate through this metal. So it will be a good thing. It's kind of safety. Okay, so let me show you my answer, and then we will see. Okay. So here you can see that the first answer is electron. The second is state and explain why the metal casing in the figure 11.1 is used. Beta particles cannot penetrate metal case. Beta particles will be directed only towards detector. So because the beta particles cannot penetrate through the metal casing, so it's kind of safety precaution. So your students or your scientists which are standing here, they will be safe from the beta particles. Okay. So the next question coming up, let me show you from the question paper, and then we'll come here. So he says, state and explain what happens to the number of particles detected in a minute as the radioactive source is moved a few centimeters further away from the source. Because you see, this source is producing beta particles, and the penetration power of the beta particles can be up to 1 meter or maybe 1.5 meter. So it's like a few hundred centimeters in the air. So if you move it just because this is being placed from the detector few centimeters away, if you move it further few centimeters towards the left, the beta particles will be able to reach the detector, so that there will be no significant change in the detector, or there might be no change in the reading on the detector, because the beta particles can penetrate through the air, and they will be able to reach the detector. If you move the the radioactive source only few centimeters to the left, okay, or if you move only few centimeters, there will be not a significant change in the. Okay, then he says more than a meter away from the source. If you move it more than a meter away from the source, then there will be the number of beta particles which will be reaching the detector, and that will reduce because some of the beta particles will be now stopped by the air. They will be absorbed by the air. So the reading on the detector will go down. It's a 2 mark question. You see, very important. So let me check the answer which I have given. So here we go. A few centimeters further away from the source, if you move the detector a few centimeters, so the penetration power of the beta particles in air is more than 1 meter. So there will be no change in the reading or a slight change in the reading. So there might be a slight change in the reading if you move just few centimeters. But if you move the source and detector more than 1 meter apart, then there will be a significant change in the reading on the GM tube. Reading will show a significant drop, beta particles absorbed by air and will not be able to reach the detector because these beta particles have few, just 1 meter or up to 1 meter penetration power. So if you move the source more than 1 meter away from the detector, so what will happen? The reading on the GM tube will significantly drop. So that was 2 mark question. See first part and second part. Okay. Now we have, let me show you the question. So here we go. Here we have a question. He says, that's the D part. A nucleus of strontium 90, SR90, decays by beta emission to a nucleus of yttrium. The sound of I is given. Yttrium. Why? Complete the decay equation for this decay. You see here the beta particle is given. The proton number of the beta particle is -1. The mass number of the beta particle is 0. So you will write here 0. Whenever a beta particle is given out, remember this thing, whenever a beta decays happen, whenever a beta particle is given out, the daughter nucleus will have proton number 1 more than the parent nucleus. So if this is 38 here, the proton number will be 39. And the mass number do not change. That remains 90. So here you write 39 and here you write 90. So let me, so okay, so nuclear fusion and nuclear fission both release large amounts of energy. Describe how the process of nuclear fusion differs from the process of nuclear fission. You see, in the nuclear fusion, small nucleus, they come close to each other under very high temperature and pressure. And those smaller nuclei, they join, they fuse into each other and they make a larger nucleus. For example, on the sun, the hydrogen and hydrogen, smaller nuclei, they come close to each other. And when they come close to each other, they fuse into one another and they make a larger nucleus. And a lot of energy is released. That is the nuclear fusion. But in the nuclear fission, what happens? We take a larger nucleus, we bombard it with a neutron, and that larger nucleus breaks into 2 or more than 2 smaller nuclei. So in the fusion, smaller nuclei fuse into each other and make a larger nucleus. In the fission, the opposite thing happens. The larger nucleus is bombarded with the neutrons and it breaks into smaller nuclei. So it's a 3 mark question. Let me show you my answers. So here you can see a nucleus. Here you can see the beta particle, its proton number is -1, its mass number is 0. The daughter nucleus, its proton number will be 1 more than the parent nucleus, and its mass number is equals to the mass number of the parent nucleus. So you write 90, 39 here 0. So let me go to this one. So he says, describe how the process, that's the E first part. So in the nuclear fusion, smaller nuclei fuse into each other to form a larger nucleus. In the nuclear fission, a larger nucleus breaks and smaller nuclei are formed. So that is the difference between them. So he says in the second part, he said, describe the conditions needed for the nuclear fusion to take place. For the nuclear fusion to take place, because the nuclei will come close to each other. Both the nuclei will have the positive charge on them, so they have very strong force of repulsion. If you want to fuse them with each other, you have to overcome that repulsive force. So for that purpose, we need a very high temperature, very high kinetic energy, and very high pressure. So very high temperature and very high pressure is required for the nuclear fusion to take place. So that was the question number E. And by this, we have reached the end of this paper. So first of all, let's have a look at the marking scheme for the question number 11. Okay. So it's very important to have a good look at the marking scheme. So you can see the marking scheme of the question number 11, which is the last question of this paper, is showing up on your screen. You can pause the video and you can have a good look. It's very, very important to always check your answers from the marking scheme. It's very important to read the marking scheme. Each and every sentence of the marking scheme you should be reading. So you can pause the video and you can have a look at the answers given in the marking scheme for the question number 11. You can pause the video and you can watch them. So that was it. And my dear students, today we have done. Okay, so you can see that we have done today we have done May-June 2021 505422 paper. This was a theory paper from the Zone 2, Variant 2. And today, in this session, we have attempted the section B of this paper. The section A of this paper we have already solved and we have uploaded in the YouTube. You can find its link in the same playlist of my YouTube. So, my dear students, at the end, I just want to say that if this video is helpful to you, if this is helping you to improve your concepts of the physics, don't forget to like my video. Don't forget to subscribe to my channel. And I will also request you that if this video is beneficial to you, don't forget to share the link of this video into your Facebook and in your Instagram. So that will be a big appreciation for me, and that will promote my channel, and it will help me. It will encourage me to do this work further. So I hope this is beneficial to you. So thank you very much, everybody. Have a good day. And it was a pleasure teaching you all. God bless you all.